So in this practice, we're finally going to learn how to graph a line using slope-intercept form, which is y equals mx plus b. We've talked about these things a lot and we've seen them in action, and now we're going to put it all together so we can graph lines without having to make a table. I think that you'll find that it's a really easy way to graph a line. So first we're going to focus on the m part, or the slope. So it's important to know that the slope is made up of two parts. It consists of a vertical change, which we're going to call the rise, and that's up and down, and a horizontal change, which we can call the run, and that's going to be left to right. So on each graph, you'll see that there's one point. We're going to use our slope, so our up-down distance and our left-right distance, to move to the next point on the line. And then we're going to fill in the ordered pair that we land on. We want to think rise over run. And we need to watch out and pay close attention to direction, like positive or negative. So here's my point, and I have a slope of 2 over 3. So that means that my rise, or my vertical change, is going to be 2. So from my point, I'm going to go up 2, 1, 2. But then I also need to move my horizontal distance, which is going to be 3. So since it's positive, I'm going to go to the right, 1, 2, 3, and I'm going to put a point there. And then when we get to the graphing part, we're going to eventually connect these with a line. But for right now, what I'm going to do is just name the point that I landed on. 1, 2, 3, 4, 5, 1, 2, 3, 4. So I'm going to say 5, 4. So for the next one, I've got my point here, and this time I have a slope of negative 1/5. So I need to remember that since it's negative, I can see that the negative is with my rise. That means I'm going to go down vertically 1, and then my run, my bottom number, is still 5. So I'm still going to change 1, 2, 3, 4, 5 to the right. And I'm going to put a point there. And that point is 2, negative 2. Now it's important to know that if I look at these 2 points and connect, I can see that that would be a negative slope. And so this kind of matches my expectation. Pause the video, try examples 3 and 4. Press play when you're ready to check your answers. So on this one, my vertical change was 6. 1, 2, 3, 4, 5, 6, and my horizontal change was 1. I landed on the point 4, 3, and on number 4, so notice that it is a negative slope. So what I need to do is to make sure I assign this negative only to one of my 2. I usually assign it to the top number. So what that meant was I went 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. If you went up 3 and over 7, then that would have connected with a positive or an increase. And if you had gone down 3 and left 7, even though we don't have room, still that would have been an increase, which makes sense because 2 negatives would make a positive. I only want 1 negative, so I went down and to the right. So now we're going to practice doing the same thing, but this time the first point that is graphed is going to be on the y-axis, which is going to be leading us to our next step on the next page. So I'm still going to use my slope of, in this case, negative 4/5, and I'm going to go down 4, 1, 2, 3, 4, and to the right 5, 1, 2, 3, 4, 5, and I'm going to go ahead and put a point there. And so I landed on the point 5, 1. And again, if I look at the connection between these 2 points, I can see that that would be a decreasing line. Pause the video, try examples 6, 7, and 8. Press play when you're ready to check your answers. So on example 6, my vertical change was 7 and my horizontal change was 3, which landed me on point 3, 3. On example 7, this one's a little bit different since my slope isn't a fraction like all of the other ones. But so what you could do is you could make it into a fraction without changing its value by putting it over 1. And so this would mean to have a vertical change of 3 and a horizontal change of 1, landing on the point 1, 3. On example 8, it's a little bit different because from this point, ideally, what I'd like to do is to change vertically by 2 and to change horizontally by 1. The problem is I haven't been given a graph that's big enough to do that. So instead of going up 2 and right 1, I can do the exact opposite. So instead of going up 2, I could go down 2. And instead of going right 1, I could go left 1. And I can see by connecting these 2 points, I still have a positive slope. And so in this case, it would land me at the point negative 1, 5. Now, if you said that it would land you at the point 1, 9 over here, technically you'd still be right. We just haven't been given a graph big enough to do that. So now we're going to put it all together. The y-intercept is going to be where the graph starts on the y-axis. That's the number where the line crosses the y-axis. They called it B. I'm not really sure why. They couldn't use y because we already have a y for the y coordinates of the points. I like to think B for begin. So we're going to start by graphing the y-intercept first, and then we're going to look at the slope to move to find the next point on the line, and then we're going to connect. So on example 9, the first point that I would graph would be 1 on the y-axis, so I would go up 1. Then I have a slope of 2/3, so that means I would rise 2, run 3, and I would put my next point. Now I have enough information to connect my line, but if I wanted to, I could actually keep doing the slope over and over and putting more points, just so that way I have a little bit more information to connect. I highly encourage doing that, but it's not a requirement. When you go to connect your line, you want to make sure you have something straight, like a ruler or even the edge of a binder, to make sure your line is straight. I'll explain everything. It's kind of hard to do that. Let's try example 10. So my y-intercept is -2. That's my second number, the one that's being added or subtracted. And then I'm going to go where my slope tells me to go. In this case, it's negative, so I know I want to go down 3 and then right 5. And then I would put my second point. And then I don't have any more room in this direction to go, so what I could do is I could go backwards from what I just did. So instead of down 3, I could go up 3, and instead of right 5, I could go left 5. And so then I could put another point right there. And so I can see all of my points are lying on a line. I can also see that when I connect them, I have a decreasing slope, which is really good news because in my equation, the slope was negative. So I want to make sure as I'm graphing, things are matching my expectations. Pause the video to graph examples 11 and 12. These just happen to be in function form or function notation, but you're still going to graph the same way. You're going to graph using the y-intercept first and then using the slope. Pause the video, press play when you're ready to check your answers. So on example 11, I started by graphing my y-intercept of -4, and then I did a vertical change of 7 and a horizontal change of 3. On this graph, that's all the points I could fit, so I was ready to connect with a line. Also notice that the line has arrows on both ends. On example 12, I started at 5 on the y-axis. Now if I had the room, I would have gone up 3 over 1, but my graph isn't big enough. So instead what I did was I did the opposite. Instead of going up, I went down, and instead of going right, I went left. And I did that over and over, fitting as many points as I could. When I connect my line, I know I'm in good shape because my line is increasing and it was a positive slope. So here's some different situations you might encounter. What if the equation isn't in function form? What if y isn't isolated, like this? Well, that's pretty simple. We could get y isolated. So in this case, I would start by adding 2x to both sides, which would mean y would equal 5 plus 2x. Now it's important to know that the slope is always the number in front of the x, and the y-intercept is always the number that's being added or subtracted. So I'm still going to start by graphing 5, and then my slope tells me to go up 2 over 1. And I can put a bunch of points in both directions to make sure I have as many points will fit on the graph. It's just going to help me connect in a more precise way. On the next one, in order to get y by itself, I first have to move 6x to the other side. So I would start by subtracting 6x, which would give me the equation 2y equals -8 minus 6x. And then I would still need to divide both sides by 2. Remember those beans? I would have -8 divided by -2, and I would also have -6x divided by -2. And so this would make my equation in function form, y equals -4 minus 3x. So I'm going to begin by graphing my y-intercept of -3 by going down 3 on the y-axis, and then I would use my slope, which is -3, although technically I'd like it to be a fraction, so I could put it over 1, and so I could go down 3 and right 1. And then I could go in the opposite directions just to plot some extra points to make sure that I have enough to really connect with something straight. And so this would be my line for number 14. So here's a real-world application of when it would be helpful to know how to graph lines. So say you've been hired to help consumers decide which cable provider they should go with. You decide the best way to present your information is on a graph and to give a pitch about the two companies. Spoiler alert, at the end of this, you're going to be giving a flip grid and completing your pitch. The information that you're given is that Fios charges an installation fee of $75 and a monthly fee of $50, and Xfinity charges an installation fee of $150 and a monthly fee of $25. So your first task is to create two equations to show the cost of each cable provider. Y will represent the cost based on the number of months X. So pause the video and go ahead and create two equations. So the Fios equation would be y equals 50x because it's $50 per month plus 75 because that's the installation fee. Xfinity would be y equals 25x because it's $25 per month plus 150 because that's the installation fee. Now we're going to graph our equations using y equals mx plus b just like we just did. So first I want you to think about where each equation is going to begin on the graph. For Fios, we'd start at 75. Now I know this is a little bit difficult to see, but I know that 75 is halfway between 150 and 100, so it's going to start there. Next, I'm going to be going up by $50 each month. So if it was 75 to start, that means after 1 month it would be $125. So I need to find 1 month, $125. After 2 months, I'd add another 50, so that means it would be $175. After 3 months, it would be $225. Go ahead and keep going in this way until you've filled in all of the possible points on the graph and then connect with a straight line. Pause the video, press play when you're ready to check your graph. So each month, the equation is going up by $50 for every 1 month. It looks a little funny because the y-axis is scaled, but the x-axis is not. Now let's graph Xfinity. So we know that Xfinity is going to start at 150. And it's going up by 25 each month. So that means that at the 1 month mark, you would have paid a total of $175. After 2 months, you would have paid a total of $200. So pause the video, continue your graph in this way, press play when you're ready to check your line. So here's what your Xfinity graph would look like. Now remember, I'm supposed to be connecting with something straight, but like I said, it's just hard to do that on Explain Everything. Now it's time to make your pitch. So make sure you go to the assignment doc in the calendar to access the link to the Flipgrid, and in 1 minute or less, you're going to help consumers decide which cable provider they should go with. Be sure to have a picture going on your Flipgrid so you can refer to it and help them decide if they should go with Fios or Xfinity based on their needs. Remember that everyone's cable needs are different, so you want to try to provide as much information as possible.